Hello everyone. We are live for the session. If you are available, just say hi in the chat window so that we can start the session. Hi Jay and Sandeep. Hi Kavita. So in this session, as I said in the previous case also, in this session we will be discussing about your Mealy machine and your Murray machine. You have a machine which is called as a Mealy machine and you have a machine which is called as a Murray machine. Okay. So I guess most of you are already present for the session. Maybe we can start. Is there anyone else who is about to come? So we can start the session here again. Fine. Hi Mary. Great, I guess most of you are already available, so we can start. So what is the definition of a Mealy and Murray machine? First of all, we will I'll show you with the help of an example what exactly is a Mealy and Murray machine. We'll start with the definition. We will see what is a Mealy and Murray machine, and I'll give you more examples afterwards. Okay. And I told you earlier also that these Mealy and Murray machines are the finite automatas, but these finite automatas produces output. So the finite automatas with outputs, there are two examples. One is a Mealy machine and second one is a Murray machine. And you have already studied these Mealy and Murray machine in your digital logic subject. I've already given you examples of Mealy and Murray machine in digital logic also. Okay, let me do one thing. First I'll give you an example maybe, and then you will understand what is how a finite automata can produce an output. Okay, I told you earlier also, let us suppose we do sum of two binary numbers. Okay, sum of two binary numbers. So there are various methods how you can do it. We have something called as a half adder. Then we created something called as a full adder. Then we created something called as a ripple carry adder, which is basically an example of a parallel adder. Okay, and then we created something called as a serial adder. Okay, so I'll show you a block diagram between difference between all four of them. First of all, I'll show you the difference, then you will be able to follow them properly. So सबसे पहला जो example है, the first example is your half adder. So what exactly is a half adder? Half adder can be used to add 2 bits of information, right? So you can add 0 and 1, so output will be 1. You can add 0 and 0, output will be 0. You can add 1 and 1, output will be 0, but carry will be 1. So basically in half adder, if this is your half adder, you give a bit which is x, you give a bit which is y, and it gives you the sum, it also gives you the carry. But the problem is it can only add 2 bits of information, not more than 2 bits of information. When you created a full adder, so in that case we can add 3 bits of information, right? So basically if you say the first bit is x, second bit is y, and the third bit is z, so your full adder takes x, y and z as input, it will produce the sum, it will produce the carry, which is very, very simple and easy. But when you look at the ripple carry adder, or let us leave the ripple carry adder first of all, let us just look at this parallel adder. So if you look at the parallel adder, so parallel adder takes some combination of bits. That means it takes something like this. If you have a number, this number, and you want to add it with this number, so this is a complete number x, this is a complete number y. Both of these numbers are 4-bit numbers. It is going to add both of them. For example, 1 and plus 1 is 0, but the carry is going to be 1. So again 1 plus 0 is going to be 1, and there is no carry. 1 plus 1 is 0, but carry is 1. So 1 plus 1 plus 0 is 0. Again the carry is 1. So again this will be as a carry and this will be as a sum, right? So in this case, what you can do is you can use these full adders to implement this ripple carry adder. What you can do is if I say the first bit here is x1, the second bit is x2, the third bit is x3, the fourth bit is x4. Here the first bit is y1, second bit is y2, third bit is y3, fourth bit is y4, and so on. So then you can mathematically formulate this as like this: x1, x2, x3, x4, y1, y2, y3, y4, and it is going to produce a sum which is s1. So the sum of these will be s1, but the carry is going to be, let us suppose it is c1. So here the sum of these will be s2, the carry is going to be c2. Some of these will be s3, the carry is going to be c3. Some of these will be s4, the carry is going to be c4. Then what you can do is, to add these two numbers, you can use, these are 2 bits, right? So you can use a half adder for this, you can use a half adder here, and the result and the carry are going to give here, and here you can use a full adder. Here also, because you have to add 3 bits, so again you can use a full adder. Here also you have to add 3 bits, again you can use a full adder. So roughly in this circuit, you are going to use a half adder here. So where you are going to give your x1, you are going to give your y1, and then this half adder will produce a sum. It will produce a carry which is c1, and you can give this carry to the next full adder. Now in this full adder, you are going to give the carry as c1, you are going to give the number x2, you are going to give the number y2, and it will produce the sum which is the next sum, which is sum s2. It will produce the carry which is c2. Again you can give it to a next half full adder, where it is going to take this carry c2, it will take the number x2, it will take the number y2, it will produce the sum s3, it will produce the carry c3. Again you can give it to next full adder, and the same procedure can go on parallelly. Okay, now if you check these out, you will identify that this is basically a parallel adder where we are trying to add these numbers parallelly. But then we have one more example, which is a serial adder. So in a serial adder, what you do is, you give these numbers serially to the serial adder. So you give this number which is 1101, which is your number x. You give the second number which is 0101, which is your number y. It will produce the sum, and whatever the carry is going to be there, it is going to store this carry in this cell, which is basically a flip-flop, right? And then it will give the carry again as a input here. So basically, how can you implement a serial adder? In a serial adder, you can use this circuit, which is a full adder. This is basically, you can use add 3 bits of information. This will become a full adder. But whenever you are going to have a carry, you are going to remember the carry in a flip-flop, and again you are going to give the carry as an input for the next bit. Okay, next value. Now for this serial adder, you can create a state transition diagram. You can say that this flip-flop might store a carry 0, it might store a carry 1. So if this flip-flop stores a carry 0, this is carry 0, then we represent it with this state. If this flip-flop stores a carry 1, then we represent it with this state. I hope it is visible, right? So if this flip-flop stores a carry 0, and we are giving these two numbers, these 2 bits as 0 and 0, then if you add 0 and 0, then the sum will be 0 and there is no carry will be produced. So it is showing this is the bit which is x, this is the bit which is y, and this is the sum, and then we are telling that if you add 0 plus 0, then the sum will be 0 and again the carry will be 0. It is showing that already there is a carry 0. So here if you add a bit which is 1 0, then sum will be 1 and again there is no carry. If you add 0 1, so the sum will be again 1, but there is no carry. But if you try and add the numbers which is 1 and 1, so sum will become 0 and carry will become 1. That means if you are going to add these two numbers 1 plus 1, then here the sum will be 0 and the carry that will be generated is going to be 1. Then this flip-flop will transition to the next state. Now here in this next state, because this flip-flop is already storing a value 1, now if you give a 0 here, if you give a 0 here, so sum will be 1 and the carry will be 0. Right, so if you give a 0 0, then sum will be 1 and the carry will become 0. But if you give the number which is 1 0, in that case sum will be 0, carry will be 1. If you give the number which is 0 1, the sum will be 0, carry will be 1. If you give the number which is 1 and 1, then sum will be 1 as well as the carry will also be 1. So this is the state transition diagram, and we have already seen this state transition diagram. हम state transition diagram को already देख चुके हैं. Sorry. So we have already seen this state transition diagram, and here you can see we are producing outputs in these transitions. ये जो output है, this is representing the outputs here. These 1s and 0, they are representing the output. Okay, so we are using a format which is, this is representing an input and here it is representing an output. So basically this state transition diagram is representing a Mealy machine. It is representing a Mealy machine. It is a diagram of a Mealy machine. Okay, now in this way you can also create a Mealy machine, but the difference is, in case of Mealy machine we represent the output in the states. So you understand that Mealy and Mealy machines are used very frequently in digital circuits. In a lot of places these Mealy and Mealy machines are used very frequently. Lot of diagrams, lot of problems that you can solve with the help of Mealy and Mealy machines. Sometimes if you need a circuit for pattern recognition, again for that case also, first of all you are going to design a Mealy machine or a Mealy machine, and then you are going to work it out to make a circuit. Okay, so you understood that there exists a Mealy machine. Now let us understand the difference between a Mealy and a Mealy machine. We will try and understand the difference, then we will move forward. Okay. By the way, how many of you understand Hindi and how many of you understand English? आप में से कितने लोग हैं जो हिंदी के साथ कंफर्टेबल है और कितने हैं जो इंग्लिश के साथ कंफर्टेबल है? Okay, good. So we have this definition for Mealy and Mealy machine. The definition says, if we have in case of finite automatas without output, the definition is like this, which is Q summation delta Q naught and F, and this is the definition for both DFA, NFA and epsilon NFA. In case of DFA, NFA and epsilon NFA, the only difference here is with this delta function. DFA, NFA और epsilon NFA के केस में आपका सिर्फ delta function में ही difference है. But in case of Mealy machine, that is with output, this definition changes to Q summation delta. Again we have delta and we have Q naught, and we use lambda and we use F. So basically there are two more tuples that we have added here, this delta and this lambda. So this delta represents possible outputs. So it is basically set of possible outputs, or you can say the output alphabet, or you can say it is the output alphabet. Just like we have summation is the input alphabet, in the same way we use this delta to represent this output alphabet. And this is your output function. This is representing your output function. I hope it is visible. आप सभी को visible है? Yes, it is visible. So that was representing an output function. Now, when we discuss about a Mealy machine and when we discuss about a Mealy machine, the only thing that changes in this entire definition is this lambda. Only lambda changes. Otherwise, delta is also same. So the definition of Mealy and Mealy machine goes like this. We have Q summation delta Q naught lambda and F, where Q is the non-empty set of states, summation is the non-empty set of input alphabet, delta is the transition function. We have already seen all of these in the previous videos, in the previous classes हम लोग इसको already देख चुके हैं, and this delta is your output alphabet. So let us suppose we can have two outputs, so it will be 0 and 1. If I have the output which is 0 and 1, so it is going to show 0 and 1. Then Q naught is representing initial state, and this is representing the output transition. I mean so the output that you are going to get, how you are going to get the output, that is the output function. So in case of Mealy machine, this lambda is Q to delta. That means if you are at a particular state, then in that state you are going to produce an output. If you are at a Mealy machine, this lambda will be Q cross summation to delta. There is a difference between both of them. So in one case you are producing output whenever you are at a state, in one case you are producing output whenever you are at a transition. Okay, इतना clear हुआ? Is it clear? So I can show the difference with the help of an example also. So जैसे कि I took the example of the sum function, or let me take another example which is an easier example here. So I'll take an easier one. So here we have a state which is q naught, and if you give an input 1, then you are going to produce the output as 0, and you are going to the state which is q1, and here if you are giving an input 0, you are going to produce the output as 0. And here this is representing q2 states, and if you are giving an input as 1, you are producing the output as 1, and here if you are giving input as 0, output as 1, and here if you are giving input as 1, output as 0, and here in this case if you are giving input as 0, output is also 0. So this is the diagram of a Mealy machine. The difference is, in a case of a Mealy machine, you are producing the output whenever there is a transition. So you can also write it down. In Mealy machine, output is produced on the transition. Output is produced on the transition. What do you mean by this is? इसका मतलब क्या है? The meaning is that if you are at a state, you are looking at an input symbol, then you will make a transition, and during that transition you are going to produce an output. For example, if you are currently at a state q naught and you have seen the input as 1, then you are going to produce the output as 0. If you are at a state q1, if you have seen the input as 0, then you are going to produce the output as 0. This is what happens in case of a Mealy machine. But if you do the same in case of a Murray machine, so in case of a Murray machine, we produce outputs on the states. Here we produce outputs on the transition. In Murray machine, we produce outputs on the states. Okay. So for example, here this is the state which is q naught, and let us suppose the output produces 1. So I'm taking this example from the book only. I'm not giving any specific example. I mean, I'm not giving my own example because I have a lot of examples. I'll be taking them in this lecture also. So this is both the same problem. So this is 0 q2, this is 0, here it is 1, here it is 1, and here it is 0. So the difference here is, in case of this machine, in case of this Murray machine, we are producing outputs on the states. यानी कि आप किसी state पर हैं, if you are at a state, you are producing an output. Here if you are making a transition, you are producing an output. Okay, do you understand the difference? तो यहाँ पर हो क्या रहा है कि अगर आपके पास, if you are at a state and you have seen some input symbol, then you are producing an output. If you are at a state, you are directly producing an output. That is your Murray machine. Is it clear? Any doubts so far? अब तक कोई डाउट है तो पूछ लीजिए. Have a look at it, write it down in notebook, or after writing, write down in the chat window. Okay, so sure. So Vandana, let me give more examples, then you will be able to understand the difference. So I'll give examples for the same problem. I'll create a Mealy machine, and for the same problem I'll create a Murray machine. So it will become much easier for you to understand. So this was just a formal definition. अभी जो मैंने बताया, that was just a formal definition. But again, let me give a better example. Okay. Example, let us suppose, create a Mealy and Murray machine. For what sense? If you have summation is equal to 0, 1, if any string is having a substring which is 0, 1, 0, then we should get an output 1. Output as 1, otherwise output as 0. Okay, so what we're trying to say is you have summation is equal to 0, 1, and there's a language, right? So in that what we are trying to do is we want to create a Mealy machine where if we give any string whatsoever, you can have any string. For example, the string can be 1 0 0 0 1 1 1 0 1 0 1 1 1 1 0 1 0 1 0. Okay, so if you give any string like this, then whenever you get 0 1 0, right? So for example, here you are getting a 0 1 0. So whenever you are getting a 0 1 0, you should produce an output 1. Here also you are getting a 0 1 0, you should produce an output 1. Here also you are getting a 0 1 0, you should produce an output 1. That means whenever in a string you have 0 1 0, you have to produce the output as 1, otherwise you have to produce the output as 0. So 0 1 0 should be a substring. Now here there are two possible cases. So the first case, that is case number 1. In this case is when we assume that overlapping patterns are allowed. Overlapping pattern is allowed. So what is an overlapping pattern? For example, here we have 0 1 0 1 0 1. Now in this case, this 0 is included in both of these combinations. So here also we have 0 1 0, and here also we get 0 1 0, and here this middle 0 is overlapping in both of these cases. So we can create a Mealy and Murray machine when overlapping pattern is allowed, as well as we can also create a Mealy machine when overlapping pattern is not allowed. Overlapping pattern is not allowed. When overlapping is not allowed, then also we have to create a Mealy and Murray machine. When overlapping is allowed, then also we have to create a Mealy and Murray machine for this example. So do you understand the problem? So problem is very simple. Let me explain the same problem in Hindi. आपके पास हमने बोला कि अगर किसी भी स्ट्रिंग के अंदर 0 1 0 आता है एज अ सब स्ट्रिंग, तो आपको 1 प्रोड्यूस करना है, और अगर 0 1 0 नहीं आएगा तो आपको 0 प्रोड्यूस करना है. अब ये जो 0 1 0 है, ये कहीं पर भी हो सकता है. यहाँ जैसे यहाँ पर है, जैसे एक बार रिपीट हो रहा है, लेकिन इस केस में यहाँ पर क्या हो रहा है, वी हैव 0 1 0 1 0, राइट. तो यहाँ पर क्या हो रहा है कि यहाँ पर जो ओवरलैपिंग हो रही है, यानी कि 0 1 0 और ये जो बीच वाला 0 है वो दूसरे वाले पैटर्न के साथ भी ओवरलैप कर रहा है. तो आप दो केसेस में बना सकते हो. पहला केस ये है जब ओवरलैपिंग अलाउड है, तो उस केस में हम Mealy and Murray मशीन बना सकते हैं. दूसरा केस ये है कि जब ओवरलैपिंग अलाउड नहीं है, तो उस केस में भी हम Mealy और Murray मशीन बना सकते हैं. So let me make for the first case. So case number 1. So case number 1 is when overlapping is allowed. Okay. So I'll create both Mealy machine as well as a Murray machine. So first of all, I'm going to create a Mealy machine. Okay. So just follow through me. You will understand it. Even while making, maybe you will not be able to understand what I'm trying to say. But after I create both of these diagram and I'll explain you how I created this diagram, then you will be able to understand. So let me create it step by step. So in the first case, what I'm trying to do is, देखो, in case of Mealy machine, initial state here is A. Okay. The first symbol can be anything. If we have 1 in the beginning, doesn't matter, we can have any number of 1s. But as soon as we get a 0, so it might happen that we can have a pattern. We go to the state B. So in state B we can have any number of zeros, doesn't matter. But if we get a 1, maybe we'll be able to find a pattern. We go to the state C. In state C, if we get a 0 again, that means we found the pattern which is 0 1 0. If we get a 0 again, we found the pattern 0 1 0. Okay. Now thing is, because overlapping is allowed, in that case we can also have a pattern which is 0 1 0 1 0 1 0 1. So here 0 1 0 is coming here, 0 1 0 is coming here, 0 1 0 is coming here. So here there are a lot of overlapping. So it can happen 0 1 0. If it is producing, then we are getting output 1. Again we can also have 1 0, right? So what we can do is we can give it like this. So from here I can give it this way. So if I get 0, I should produce output as 1. Okay, so this is if we have overlapping which is allowed. Okay, So here for A we have given output for 1 and 0, for B we have given output for 1 and 0, for C we have given output for 0, but we have not given output for 1. That means if you have a string like this 0 1 1 1 0 1 1 0 1 0, right? So here after first 0, after second 1, here the second, this next symbol can be 1 also 1. So in that case again we have to search for the pattern. That means if we get a 1 here, I'll go to the state A and I will produce output as 0. So you can see this diagram, whenever we get a pattern 0 1 0, it should produce an output 1. So let me check it out. If we have a pattern 1 1 0 1 0 0 1 1 1 0 1 0 1 0. So if we give this pattern to this, what happens? First 1 is there, from state A to state A, output is 0. Then again 1, state A to state A, output is 0. Then we have 0, from state A to state B, output is 0. Then we have 1, so state B to state C, the output is 0. Then we have 0, from state C to we'll go to state B and we are going to produce output as 1. So here the output 1 will be produced. Now we are currently at state B and we got a 1, so from B we go to C and we got 1 again, so from C we go to state A, output is 0. Again we got 1 from A to A, then again we get 0 from A to B, from again we get 1 from B to C, again we get a 0 from C to B, and output is 1. So here we are going to produce output as 1. Again we are getting a 1 from B to C, again we are getting a 0 from C to B, again we are producing output as 1. So whenever we get a pattern which is 0 1 0, it will always produce an output as 1. तो जब भी आपके पास 0 1 0 पैटर्न होगा तो हमारे पास आउटपुट 1 होगा. Now in case of a Mealy machine, what happens is we will produce an output when we are at a state. Okay. So currently we are at state A, we are producing output as 0. Okay. In beginning we can have any number of ones, doesn't matter. But as soon as we get a 0, it can happen that our pattern is about to reach, so we go to the state B, producing output as 0. If we get a 1, we go to the state C, we are producing output as 0. Is it visible so far? Yes, it is visible. Now if we get a 1, we go to state D and we are producing output as 1. Okay, so this is the basic skeleton. Now we have to tell in case of state B, if we get one more 0, what happens? So if we get one more 0, we go to the state B also. In case of state C, if we get a 0, state C में हमने 1 के लिए output दिया, we have given output as for 1, but we have not given output for 0. So in case of state C, if we get a 0, then we go to this, right? So this is basically a 0 because 0 1 0, right? So if we got a 1 here in state C, अगर आपके पास 1 आता है, if we get a 1 in state C, we go to the state B. And again we have to search for, actually in that case we have to go to, instead of state C we have to go to state A because we have to search for the entire pattern again. Now in case of D, if we get a 1, we go to state C. In case of D, if we get a 0, then again we have to go to the state B. So just have a look at it. What we are trying to do is, we can have any number of ones in the beginning of the pattern. Then if you get a 0, there's a chance that we might get 0 1 0. We go to B, again we can have n number of zeros. If you get a 1, so there's a chance that we might get again 0. So in C, if you get 0 1 1, so we have to search for the entire pattern again. But if we get a 0, we go to the state B, we produce output as 1. And here in the state D, if again there's a 1, so because it is an overlapping pattern, so we go from state D to state C. And again if you get a 0, so again output 1 will be produced and so on. But here if you get a 0 again, so we have to go to the state B to search for 1 0. So this is how this Mealy machine looks like. So you can see this is a Mealy machine and Mealy machine, both are solving the same problems. In case of a Mealy machine, you are getting the number of states as 3. In case of Mealy machine, you are getting the number of states as 4. So try and give any input here. Let us assume I give an input which is 1 1 1 0 1 0 1 1 1 0 1 0 1 0 1 1 1 0. You want to give this output to this Mealy machine. What happens is, you are giving 1 from state A, you are at state A. You are again giving 1 from state A, you are at state A. Again you are giving 1 from state A, you are at state A. Now you are giving 0 from state A, you are going to state B. Now again you are giving 1 from state B, you are going to state C. you are giving 0 from state C, you are going to state D, and in this case we are producing output as 1. So you can see 1 0 1 0 is there, so we are producing output as 1. Now we have 1, so from state D we are going to state C, output is 0. Again 1 from state C we are going to state A, output is 0. Again 1 from state A to we are going to state A itself. Now we got a 0 from state A, we go to state B. We got a 1 from state B, we go to state C. We got a 0 from state C, we go to state D. Now again we produce output as 1 here. Again we get a 1 from state D, we go to state C. Again we get a 0 from state C, we go to state D, and here also we are producing output as 1. So whenever, even if you have an overlapping pattern here, you are still producing output as 1 1. Is it clear to all of you? क्या आप सभी को clear है? What is the difference between Mealy and Murray machine, and is this example clear? क्या आप सभी के साथ ये clear है? Is it clear with all of you? कोई डाउट है तो प्लीज आस्क. Okay, somewhat clear. So let me take another example here. So as I told you, the second example is with overlapping pattern not allowed. When the overlapping is not allowed, so this example will change. Okay. Let me take the second case. Let me keep this diagram here, and I will make the second diagram above this so that you can understand the difference between both of them. So what we want is that if we have 0 1 0 and overlapping is not allowed, in this case overlapping is allowed, and in the next case when overlapping is not allowed. Overlapping is not allowed. Okay, so when overlapping is not allowed, then this will be very different. Okay, so let us see. Initially we are at a state A. We can have any number of ones in the beginning. We are going to produce output as 0. As soon as we get a 0, we'll go to the state B. We will produce output as 0. We can have any number of zeros whatsoever. As soon as we get a 1, we go to state C and we will produce output as 0. Now in this case, the special case is if overlapping is not allowed, then here if I get one more 0, so we are going to produce output as 0. Again we have to search for the entire pattern. So here this transition changes. If we get a 0, we'll produce output as 1, and we have to search for the entire pattern again. And here if we get a 1, then we produce output as 0, and again we have to search for the entire pattern. So this is the difference here in this diagram. Here if overlapping is allowed, this is the diagram, this is the transition, but if overlapping is not allowed, then from C we can go to state A again. And in this case, let us see, originally we are at state A, producing output as 0. In the beginning you can have any number of ones. Then if we get a 0, we go to the state B, we are producing output as 0. If we get any number of zeros, doesn't matter. If we get a 1, we will go to the state C, we will produce output as 0. Now in this case, at state C, if we get 0, we go to the state D, we are going to produce output as 1. But again there will be a difference in this case. What is the difference? After 0 1 0, we have to search for the entire pattern again, correct? So at state D, if you get a 0 again, so that should be 0 1 0, right? Okay, so if you get a 0 again, you go to the state B, and if you get a 1, so you have to search for the entire pattern again. That means if you get a 1, you go to the state A. So what is the difference? In this case, if you get a 0, you are again going to state B, but the difference is if you get a 1, so because overlapping is allowed, so as soon as you get one more 0, you should be able to produce 1 as output. But here, as soon as 0 1 0 happened, you have to search for the entire pattern again 0 1 0 should be there. Okay, and here in state C, if you get a 1, we should go to this state. So this is the difference when overlapping is not allowed, and this is when overlapping is allowed. So this is this clear to all of you? Ab clear hua? So let us try and give some input, and then you will understand the difference. Okay, assuming we have the input as 1 0 1 1 1 0 1 0 1 0. Okay, this is the input. Now we give this input to this one, and we give this input to this one. So if you give this input to this one, to kya hoga? So by giving this first one, by giving this one, we go from state A to state A. By giving this 0 from state A to state B. By this giving this one from state B to again state C. So by giving this one from state C to again we come back to state A. By giving this one from state A, again we go to state A. By giving this 0 from state A, we go to state B. By giving this one from B, we go to state C. By giving this 0 from C, we go to state D, and here we produce output as 1. Now we get a 1 from state D, we go to state A. We got a 0 from state A, we go to state B. So after reading this entire string, we are only producing output 1 only one time, otherwise we are producing output as 0. And the last state is state B. But if you give the same input to this one, so the input is 0 1 0 0 1 0 1 0. Now in this case, what will happen? The first input is 1, so we go from state A to state A. Then we got a 0 from state A to state B. Then we got a 1 from state B to state C. Then again 1 from state C to state A. Then again a 1 from state A to state A. Then again a 0 from state A to state B. Then again a 1 from B to C. Then again a 0 from C to D. And here we are producing output as 1. Then again 1 from D to C. And again 0 from C to D, and here also we are producing output as 1. So here in this diagram, if you give this input, we are producing output 1 2 times, and here we are producing output 1 only one time. So this is the difference between both of them. So this is representing your Mealy machine, this is representing your Mealy machine. So whenever you have a Mealy machine, so in this case you are going to produce outputs in the state. Whenever you have a Mealy machine, you are going to produce output in the transitions. Is it clear? Sanjeev, it is not always the case, but in most of the time, number of states in a Mealy machine is going to be more as compared to the number of states in the Mealy machine. Okay. If you understood this, please hit like, and if please write this down in your notebooks and write down in the chat window, so that I can rub it up. So I can rub this screen. Any doubts, please ask. Okay, Sonia, I think you have not studied, you are studying it for the first time, you are studying the class for the first time, that is why I could not understand. So maybe you can follow the last 6 lectures. just try and follow the last 6 lectures. This is the 7th lecture, so maybe you'll be able to understand this diagram. Okay, so let me rub it up and I'll clear and create more diagrams. So because you are following this lecture, this is your 7th lecture, that is why you are not able to follow this one. So first of all, please go through the first 6 lectures and follow this 7th one after that, or you can just watch my some of my pre-recorded videos. Okay, let me take more examples. I have some examples here. Okay, sure. So let me take more examples here. I'll take same type of example, assuming that we have a pattern which is 1 0 1 1 0 1. Make it smaller instead of bigger pattern. Let me make it 1 0 1 1. So what we want to say is, if in any string this pattern is there, we should produce an output as 1. अगर किसी भी string में 1 0 1 1 एक pattern है, तो string is on summation is equal to 0 comma 1. If in any string we have this pattern 1 0 1 1, then we want to produce the output as 1. Otherwise, we want to produce the output as 0. So this string this is again an example from digital logic, and whenever you have this Mealy and Mealy machine, you can easily convert them in a circuit diagram. So first of all, let me do one thing here. I'll create a Mealy and a Mealy machine for the same pattern, and then I will create a state transition table for this. And let us say that here overlapping is allowed. Overlapping allowed hai. So in that case, I'm going to create a diagram and then I'll create a state transition table. So first of all, I'll create a Mealy machine. Initial state is A. So if you get zeros in the beginning, any number of zeros, no problem. We are going to produce output as 0. If you get a 1, you go to the state B, you are going to produce output as 0, because maybe we can find this pattern. Now again, if you get a 0 after this, if you are at state B and you might get a 0, then you go to state C, you are going to produce output as 0. But here in state B, if you get a 1, you go to state B itself, output is 0. If you get a 1, then you go to state D, you are going to produce output as 0. And if you get a 0 here, then you have to search the entire pattern again. So you go to state A and produce the output as 0. In state D, if you get a 1, you go to state E and you want to produce output as 1. But again, because overlapping is allowed, so what I'm going to do is I'm going to take a transition from state D to state B, and I'm going to say state D to state B. So if it will be 1, the output will be 1. So because if overlapping is allowed, so if we have the pattern like 1 0 1 1 0 1 1, so in this case 1 0 1 1 is here as well as 1 0 1 1 is here. So if overlapping is allowed, then if I get 1 0 1 1, then I should only need 0 1 1 again to produce the output as 1. And in state D, if you get a 0, then maybe I should get something like this 1 0 1 0 1 1, right? So 1 0 1. After this one, if you get a 0, again we have to search for 1 1, right? Sorry. So if you get a 0, we go to state C and we are going to produce output as 0. Okay, so take any pattern and let us see if it is working or not. If I have the pattern which is 1 1 1 0 1 1 0 1 1 0 1 1 1 1 1 0 1 1, right? So here how many times 1 0 1 1 is there? So we have a 1 0 1 1 here, we have a 1 0 1 1 here, and we have a 1 0 1 1 here, and we have 1 0 1 1 here. So that means if you give this pattern to this, so we should produce output 1 4 times. So 4 बार आपका output 1 आना चाहिए. So first 1 is given. So from state A we go to state B, output is 0. Again 1 is given. From state B we go to state B, output is 0. Again 1. From state B we go to state B itself, output is 0. when you get a 0 from state B, we go to state C, output is 0. When you get a 1 from state C, we go to state D, output is 0. Again, when you get a 1 from state D, you go to state B and output is 1 here. So that means here you are at state B and you produce output as 1. So if you get a 0 from state B, we go to state C, output is 0. If you get a 1 from state C, we go to state D, output as 0. Again you get a 1 from state D, we go to state B, output as 1. So here also we are at state B. Now if you get a 0 from state B, we go to state C, output is 0. If you get a 1 from state C, we go to state D, output is 0. For again you get a 1 from state D, we go to state B and output is 1. So here also we are at state B. Now if you are getting 1, so you will be at state B, again 1, state B, again 1, state B, again 0 from state B to state C, output is 0, again 1, state C to state D, output is 0, again 1 from state to state B, output is 1. So you can see if you give this pattern, so in that case you are producing output as 1 4 times. Okay. Now if I create a Mealy machine for this, the Mealy machine will look something like this. Initially you are at state A, you are producing output as 0. In beginning you can have any number of zeros. As soon as you get a 1, you go to state B, you are going to produce output as 0. In state B you can get any number of 1, but if you get a 0, you go to state D, C, this is state C, and output is 0. Okay. Now in state C, if you get a 1, you go to state D and again output is 0. So till this time we got 1 0 1, right? And in state C, if you get a 0, then you have to search for this 1 0 again, correct? Now in state D, if you again get a 1, you go to state E and you are going to produce output as 1. But in state D, if you get a 0, so we have to search for 1 1 again, okay, because it is 1 0 1 1. And in state E, if you get a 0, then you have to search for 1 1 again. And in state E, if you get 1 again, then you have to search for 0 1 1. So this is your diagram. Okay. So you can identify how many number of states are here. Now if you create a state transition table, I hope this text is visible, state transition table, yes it is visible. So in case of Mealy machine, you are going to write what is the input and what is the output, right? So we are going to write input and output. Here also we are going to write input and output, okay? So instead of this, let me represent it in another fashion. Let me say this is for the input 0, this is for the input 1. So I'm going to represent what is the next state and I'm going to represent what is the output. Okay. So here we have 1, 2, 3, 4. There are 4 states, which is A, B, C and D. In state A, if you give a 0, you go to state A again and output is 0. So you go to state A again, output is 0. In state A, if you give a 1, you go to state B and output is 0. In state B, if you give a 1, you go to state B again, the output is 0. In state B, if you get a, sorry, this is for 0. For 0, you go to state C and output is 0. For 1, you go to state B and output is 0. In state C, if you get a 1, you go to state D and output is 0. In state D, C, if you get a 0, you go to state A and output is 0. In state D, if you get a 0, you go to state C and output is 0. In state D, if you get a 1, you go to state B and output is 1. This is the state transition diagram in this case when we have a Mealy machine. In the same way, we can also state transition diagram for a Mealy machine. In this case, it will be a Mealy machine. So what is the difference in this state transition diagram? In case of state transition diagram of a Mealy machine, we have written next state as well as output together, but here I'm going to write a next state here and output separately. So here I'm going to write the next state when you give input as 0, when you give input as 1, and here this is the output. So basically, because we have 5 states, so I'm going to write 5 states here, which is A, B, C, D and E. And output for every state: for state A, the output is 0. For state B, the output is again 0. For state C, the output is 0. For state D, the output is 0. and for state E the output is 1. So I'm going to write outputs separately, and the inputs you can see next state. If in state A, if you give a 0, you go to state A. In state A, if you give a 1, you go to state B. In state B, if you give a 0, you go to state C. In state B, if you give a 1, you go to state B. In state C, if you give a 0, you go to state A. In state C, if you give a 1, you go to state D. In state D, if you give a 0, you go to state C. In state D, if you give a 1, you go to state E. In state E, if you give a 0, you go to state C. In state E, if you give a 1, you go to state B. So this is the state transition diagram of this Mealy machine. Please write it down and ask if you have any doubts. I hope this much is clear with all of you. Do you have any doubts so far? Please have a look at it, note it down, and ask if you have any doubts. Yes, but in other examination they ask about Mealy and Mealy machine frequently, so that is why I covered. So there's a chance that you might get a question on Mealy and Mealy machine in the NTA net. उसका कुछ chance है, so sorry. Is it done? So let me clear it up. Can you write done in the chat window if you have written it down? So you can get various types of questions regarding Mealy and Mealy machine. I'll just write one very common question that you generally get. The question is like this, that a Mealy machine takes a binary number as input and produces its ones complement as output. Or sometimes you can also get a question like a Mealy machine or a Mealy machine takes a binary number as input and it produces 2's complement as output. Okay, so you can easily get questions like this. I can solve these questions here. Okay, let me just solve them. The first example is you have to take a binary number as input and you have to produce one's complement as output. And second example is you have to take binary number as input and you have to produce 2's complement as output. Okay, so in the first case is very easy. I hope all of you can easily do the first case. फर्स्ट केस में कुछ भी परेशानी नहीं है, बहुत ही इजी है. तो फर्स्ट केस में करना क्या है, बट व्हाट डू हैव टू डू इन द फर्स्ट केस. इन केस ऑफ Mealy machine, this is the initial state A. If you produce a input, if you get an input 0, change it to 1. If you get an input 1, change it to 0. That's it. Very easy. Okay, only with the help of one state you will be able to solve the first case, correct? Because 1's complement is every 0 is converted to 1 and every 1 is converted to 0. Okay? And then you can easily convert this Mealy machine to Moore machine. So I'll also tell you some of the examples that how can you convert a Mealy machine to a Moore machine and how can you convert a Moore machine to a Mealy machine. Okay? So a Moore machine for this will look something like this, that initial state is A with output as 0. If you are giving input as 1, then you are going to get output as 0. If you are giving input as 0, you are going to the state B and you are producing output as 1. In B, if you are giving input as 0, you are going to produce, you will be in the state B, you are going to produce output as 1. And if you are giving input as 1, you go to state A, you are going to produce output as 0. This is a Mealy and Moore machine. If you give any binary number as input, which is 110, 1101, it will produce the 1's complement of this. You can give this input here, you can give this input here, and you will get a 1's complement in these cases. Okay? But this 2's complement example is very interesting. 2's complement jo hai, it is interesting. And how can you say that 2's complement is interesting? So there are many ways of finding out 2's complement. Let me explain you with the help of an example. If I have a number which is 0, 0, 1, 0, 1, 1, 0, and you want to find a 2's complement for this, first of all you need to find 1's complement, right? So 1's complement will be 1, 1, 0, 1, 0, 0, 1. And then you are going to add 1 to find the 2's complement. So it will become, here it will become 0, this will be 1, okay? And then here it is 0, 1, 0, 1, and this is going to be 1. So this is your 2's complement. Okay, in the same way, if we have an input as 1, 1, 1, 0, 1, 1, 0, 1. Okay, so here first of all you can find the 1's complement. So in the 1's complement you will get something like this. This 1 will be converted to 0, 1, 0, 0, 1, 0, 0, 0. And then you can add plus 1 to this so that you can find 2's complement. This will become 0, 0, 0, 1, 0, 0, 0, 1. So this will be the 2's complement for this number. Itna clear sabko? How can you find the 1's complement and the 2's complement? So directly from this input also you can find this output. Directly from this input also you can find this output. So how can you do it? Let me take you one more example and then you will be able to understand it more clearly. Assuming that we have the input as 0, 1, 1, 0, 1, 0, 0, 0, 0, 0, right? Take it here 1, 0, okay? So find the 1's complement of this. 1's complement will be 1, 0, 0, 1, 0, 1, 1, 0, 1, 1, 1. This is the 1's complement. And the 2's complement, just add 1 with it. It will become 1 plus 1 is 0. Again 1 plus 1 will be 0. 1 plus 1 will be 0. This will become 1. And here we have 1, 1, 0, 1, 0, 0, 1. Okay. So this is representing the 2's complement. Okay. Now in this case, interesting part is when you find a number, binary number, and you find the 2's complement of that binary number, we read from right to left. This is the right hand side, this is the left hand side, so we read from right to left. So from the right, if we get zeros, we are keeping these zeros as it is until we get the first one. All these things are as it is, all these things are as it is here, and after this we are going to reverse every bit. After this we are going to reverse every bit. So here also you can see, if you go from left to right, जो सबसे जितने भी जीरो आएंगे सबको as it is लिखना है, और जो पहला वन आएगा उसको as it is लिखना है. You have to write the first one as it is and then you have to reverse everything. So for example here, this is as it is and everything else is reversed. And here on the left hand side, because we do not have any zeros but we directly have a 1, so we are going to write this one as it is and we are going to reverse every single bit after that. So this everything will be reversed. Correct? So this is how you can do it. But if you want to have a Mealy and Moore machine, then in case of Turing machine it becomes very easy to create a Turing machine for this. But for a Mealy and Moore machine, you can assume there should be an assumption. You can assume that we are reading the string from right to left. If we are reading the string from right to left, then in beginning all the zeros we are going to read all these zeros as it is. If you get first one, you are going to give this first one as it is, and then you are going to reverse everything. So what I am going to assume is assuming we are reading string from right to left. From right direction to left right direction we are reading the string. So in that case, if I am creating a Mealy machine, so this is the initial state A. So in the beginning you can have any number of zeros, you are going to keep all the zeros as it is, and then you get the first one, you are going to keep the first one as it is, you go to the state B, and after this you are going to reverse every bit. So you can, if you have a 0 you can produce 1, if you have a 1 you can produce a 0, and this is how you can easily do it. Is it clear? इतना सबके साथ क्लियर है? Any doubts? Okay, no problem, Sonia. As I said, this is your 7th lecture, so because you have not attended any classes before, let's do one thing. We can have a call after the class, Sonia. I think ma'am added you in the group today, so we will have a call after the class. Then I'll tell you how to read from the classes, how to study, so that you can understand. Okay? So there is no doubts. Okay. So the next example is how can you convert a Mealy machine to a Murray machine, and how can you convert a Murray machine to a Mealy machine. So we have conversions here. Conversions. So there are two types of conversion. The first conversion is from a Murray machine to a Mealy machine, and second conversion is from a Mealy machine to a Murray machine. Murray machine to Mealy machine and Mealy machine to Murray machine. So in this case, the first conversion is very easy. It is very easy. And the second conversion is very easy. Okay, so if you have some kind of quantity to measure which one is easy, which one is very easy, so you can say 4 easy, 4 very means it is very easy, 2 very means it is just easy. So let me show you the help of example. Let us suppose we have a Murray machine for the pattern which is 1101. That means if in a string we have 1101 as a if we have 1101 as a sub pattern, then we want to produce output as 1, or make it small. Let us assume we have pattern as 110. तो यानी कि अगर किसी भी string में आपके पास 110 है, then we have to produce output as 1. Otherwise, we have to produce output as 0. And we have a Murray machine for this. So Murray machine is something like this. Initial state is A, output is 0. You can have any number of zeros in the beginning. As soon as you get a 1, you go to the state B, output is 0. As soon as you get one more 1, you go to the state C, output is 0. As soon as you get 0, you go to the state D, and you are going to produce output as 1. Okay. Now in B, you can have input as 0, you go to the state A. In C, if you get input as 1, you are at state C itself. In D, if you have an input as, let us suppose this pattern is overlapping. So if you get an input as 1, you go here. And if you get input as 0, so you go here. This is your Murray machine for this. Okay. Now to convert this Murray machine to a Mealy machine, it is very easy. बहुत ही ज़्यादा easy है. Conversion of a Murray machine to Mealy machine is so easy that you will not even imagine कितना easy हो सकता है. बस करना ये है, हमें करना ये है, wherever we have an input transition, तो हमें इस output को input transition में transfer कर देना है. That's it. I can just change this Murray machine to Mealy machine within this diagram. How can you do it? Wherever you have input, I mean, if this is an incident, right? So we have outgoing edge and we have an incoming edge. So we have to just shift this output to the incoming edges, right? So for example, here we have incoming edge here. So just write this output here. We have an incoming edge here. So write this output here. We have incoming edge here. Write this output here. Okay. So for B, we have two incoming edges. B is producing output as 0, so I'm going to write the output in both incoming edges, and that is done. For C, we have two incoming edges, this one and this one, so I'm just going to write 0 here, and it is done. And for D, we have only one incoming edge, so I'm going to write input here, and this is also done. So now you can clearly see I have converted this Mealy machine to Mealy machine. All I have to do is you have to shift these output which is written in the states on the incoming edges. आपको बस ये जो output जो states में written है उसको incoming edges में shift करना है. Clear? Okay. So you have to shift these outputs which are in the state to the incoming edges. That's it. So this is how you can convert a Mealy machine to Mealy machine. Now this is a Mealy machine which is for that given Mealy machine. So obviously you can have more number of states, and then we might have to minimize this Mealy machine, but the minimization of Mealy and Mealy is not in our syllabus, and we don't really have to cover it, because in any of your examination they do not ask minimization of Mealy and Mealy machine. वो Mealy और Mealy machine की minimization नहीं पूछते हैं. So maybe it is very easy. How can you convert a Mealy machine to Mealy, and how can you convert in the same way we will see how can you convert a Mealy machine to Mealy. Okay. So let me convert a Mealy to Mealy. So Mealy को Mealy में कैसे कन्वर्ट करना है? जो भी इनकमिंग एज है जिस स्टेट पे, आपको आउटपुट बस वहां पर लिखना है और आउटपुट को स्टेट के अंदर से डिलीट कर देना है, एंड दिस इज हाउ यू कैन इजीली डू इट. ओके. Let me give you an example. The example that I've taken before also. This is a Mealy machine. This is the state Q1. This is the state Q2. Here, if you give input as 1, you get output as 0. Here, if you give input as 1, you get output as 0. Here, if you get input as 0, output is 0. Here, if you get input as 0, output is 1. Here, if you give input as 1, output is 0. And this is 0 and 1. 0 and 0. Okay. Now we have to convert this Mealy machine to Mealy. अभी आपका सेकंड केस है जहां पर हमें इस Mealy को Mealy में कन्वर्ट करना है. पहले केस में क्या था? The first case we have converted Mealy to Mealy. Now we have to convert a Mealy to Mealy. Very easy, nothing difficult, very easy example. जय, are you there in the chat? जय, क्या आप चैट में हैं? आप क्लास में हैं इस समय पर? So let me convert this up. What you have to do here is, in this case, if there is an output on this transition, the output which is on the incoming state, right? तो जैसे वहां पर हमने क्या किया था, in a Mealy to Mealy we have given the output which was present in the state to the incoming transitions. Here we have to just shift this output from the incoming transition to the state. That's it. Okay. So how we can do it? Initial state is Q0, and this was the state Q1. So this is a transition that if input is giving 1, the output is produced as 0. So I can just give this 1 here, and I can write 0 here. In this transition, if input is 0, output is 0. So I'm giving 0 here. Okay. Now if you look at this Q2, now this Q2 was interesting. Why? Because here we are producing output as 1, and here we are producing output as 0. Okay. Now if we have a state where we have different outputs, जैसे कि in Q2 this transition producing output as 1, this transition is producing output as 1, and this transition is producing output as 0. That means we have to make two copies of Q2. I'm going to create a copy which is Q2 1. I'm going to create a copy which is Q2 0. Okay, so this is producing the output as which is 1, and this is showing the output as 0. So to differentiate between both of them, I'm going to say this state as Q21, and I'm going to say this state as Q20. Okay, just to differentiate between their names. Okay, now what I'm doing is, in Q1 if you give a 1, you go to Q21 because you are producing output as 1. Okay, and in Q0 if you are giving a 0, you go to Q2 to 1 because you are still producing output as 1. In Q2 if you are giving a 0, you are going to Q2 again, but output is 0. Okay, here also if you give a 0, you are going to Q2 again, which is output is 0. And then for the outgoing transition in Q2, if you are giving 1, you are going to Q0 and output is 0. If you are giving 1, you are going to Q0, output is 0. And here also, if you are giving 1, you have to go to Q0 and output is 0. That's it. Very easy. All I have to do is, if for a state we are producing multiple different outputs, for example here we are having an incoming transition for Q2 where we are producing output as 1, and here we are producing output as 0. So for Q2 we had two different outputs. So what I have to do is I have to split this into two different states. One state will be producing output as 1, another state will be producing output as 0. So any incoming transition where output is 1, I am going to give it to this state. Any incoming transition where output is 0, I am going to give it to this state. Okay, and all the outgoing transitions will be same as it is, because we have created two different states. So from both of these states we have to produce outgoing transitions here. Okay, so now you can clearly see I have converted this Mealy machine to a Murray machine, and this Murray machine is having 4 states and this Mealy machine was having 3 states. And this way you can easily convert a Mealy machine to a Murray machine. Okay, so I hope that you understood this. So I have taken only one example of conversion from Murray to Mealy and from Mealy to Murray. If you feel like you are still not able to understand this conversion, please let me know. Please write in the comment section also in the chat window if you want me to take more examples. But I feel one example is enough to understand how can you convert a Mealy to Murray and how can you convert a Murray to Mealy. So in this entire session we have seen what is a Mealy machine, we have seen what is a Murray machine, we have seen how can you convert a Mealy machine to a Murray machine, we have seen how can you convert a Murray machine to Mealy machine, and we have taken a lot of examples. I hope that you found this lecture useful. आप सभी को useful लगे तो like कर दीजिएगा lecture को, please like the video. और let us take the next class. तो next class जो है I'm going to update the next class in the Telegram group, and in the next class I'm going to cover more examples of finite automatas, some tricky questions of finite automata, that if for this language can you create a finite automata or not. I'm going to cover some of those tricky questions, and then we will be looking at what is a push down automata. I'm not taking any previous questions till now. Why I'm not taking any previous question? Previous question क्यों नहीं ले रहा हूँ? Because I want to cover push down automatas first before I take any question on finite automata and push down automata. So there's some portion of the theory that we have to cover. We have to cover push down automata, we have to cover regular expressions, then we have to cover what is the difference between a context free language and what is the difference between a regular language. Okay, after covering these sections, then only we will be able to take some of the previous questions, because till that point of time we do not even have enough knowledge to take questions, right? So classroom में ऐसा होता है, in most of the classroom you cannot take questions unless we teach till push down automatas. After I teach push down automata, I'll take previous questions also, so that you will be able to prepare accordingly. Okay, so Sanjeev, you can call ma'am about how to join Telegram group. So you can write the number. I'm writing the number in the chat window. So you can call on this number if you want to join the Telegram group. And all the classes, see, all the classes that we do, these are not public classes. So only this subject, theory of computation, I'm doing live for everyone, so that everyone will be able to join the session. But if you want to join the regular classes, you can call on the numbers that is given in this chat window, which is 9821876104. So if you want to join the classes, you can call ma'am on that number. Otherwise only this subject I'm doing live on this channel. Otherwise most of the live classes are private. Okay, and I think Sonia, I think you joined the sessions today. Just give a call after 5 minutes and let me have a discussion with you. And others, that's Mary, Jay. I think Jay is not present here. If you have any doubt, please send the Telegram group. I'll update the timing of the next class in the group itself. Okay, chalo, bye bye and take care. सभी लाइक कर दीजिए वीडियोस को.